Okay, Ireland. There's a couple different kinds of factoring you have to do on a problem like this. And the first one, the most important one that you should always look for is to see if there's a greatest common factor, a factor which is in every term. And in this case, there is, and it is p, right? The first term has p to the third power, which means it's p times p times p. The second term has p squared, which is p times p. And the third term has p to the first, which is there once. So every term has p in it at least once. So factor out a p, right? That's the first part of it. Okay, to factor a p from p to the third, there's a p squared left. If I factor one of the p's from p squared, I still have 4yp. And if I factor p, the only p, from the last term, then I have 4y squared. Okay, now I believe in your problem that may have been one of the answers. So it said which is not the correct factoring. So letter B would have been a correct factoring. That's just the first step. Okay, next, go back. Right, it's always a little more confusing when you see a quadratic expression like that and you have two different variables. Now, if I gave you something like x squared minus 4x plus 4, and there was only one variable, then you would think of it like this. You would say, what are the factors of positive 4 that add up to negative 4? And that would lead you to say x minus 2 times x minus 2, right? Or x minus 2 squared. Well, if what you have is not x minus 4x, x squared minus 4x plus 4, but x squared minus, let's say, 4xy plus y squared, all that means is that the second term, it's not just x minus 2, it's x minus 2y, and x minus 2y, and x minus 2y squared. Right? Your problem is different only in that they use p instead of x. Right? So this would factor like this: p times p minus 2y times p minus 2y, which is p minus 2y squared. Okay, go back to your problem. So what I came up with at the end, we've already seen that this first one, this letter B, I already produced that one. I just produced letter C. And you could see letter A is what you would get if you multiplied the P that we already factored out times one of the P minus 2y's. Right? If I, like in this step right here, to make it look exactly like they did, right, I'm going to say this P, I'm going to multiply times that. I'm going to use it to distribute in the second parentheses, right? And that would give me P minus 2y times P squared minus 2yp. Now let's see if that's not right. So that now it's exact. So we've made through my factoring on the other screen A, B, and C. The only one which you would not be able to make would be letter D. So that the correct answer was letter D. What was I going to say? 4yp negative p plus. Well, I'm trying to see here that we do have this exactly correct. P to the third. What if we factor out a 4yp from here and a 4yp from here? What would be left? Negative p plus y. So I'm kind of curious here. Because in a sense, you could see how they factored only the second two terms. Oh, no, 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 no. Let's see. Yeah, this would still be incorrect because they got the signs of these things wrong. I mean, if I multiply negative 4yp times y, I would get negative 4y squared p. And that's a positive 4y squared p. Right? And if I multiply negative 4yp times negative p, that would be positive 4yp squared. But that's negative. So that's why this one right here is still not the right answer. And I know my screen just kind of shifted there, but that's okay. So anyways, remember when you're factoring to always look for greatest common factor, GCF. Factor that out before you do anything else. And if you seem like more than one variable in there and it's confusing you, you could always just take out the second variable. I mean, it's going to start with p squared, so keep the p, but maybe drop the y and try to factor what's left, like I did there, and then add back in the second variable. So I hope that helps.